Betelgeuse, the red Goliath star balanced on the edge of our cosmic system, is conveying unfavorable messages through the universe. Using the James Webb Space Telescope, astronomers have discovered something about this enormous planet that is extremely unsettling. Eminent astrophysicist Brian Cox gives a grave admonition. Would we say we are on the slope of seeing a devastating cosmic explosion blast that could perpetually change the night sky as far as we might be concerned? Let's start. In the great embroidered artwork of the universe, where stars are conceived, live, and pass on in marvelous style, one star has as of late caught the creative mind and worry of cosmologists and the public the same. This star is Betelgeuse, a red supergiant of gigantic extents and age, arranged obviously in the heavenly body Orion. Its particular rosy tone and variable brilliance have for some time been a wellspring of interest. However, ongoing improvements have strengthened interest in this heavenly Goliath. We are on the verge of a potentially significant occurrence in the star's life cycle as we investigate Betelgeuse's nature. But what could these Betelgeuse changes mean? Is this the prelude to a cosmic spectacle of unfathomable magnitude? A stellar colossus, Betelgeuse is approximately 764 times larger than our Sun. It is almost impossible to comprehend its immense size. Imagine a star of such immense size that, if it were to take the place of our Sun, its surface would extend beyond Mars' orbit, covering Mercury, Venus, Earth, and Mars. This extraordinary size isn't simply a demonstration of Betelgeuse's actual characteristics, yet in addition addresses its stage in the heavenly life cycle. Betelgeuse, a red supergiant, is in its twilight, a period of expansion and cooling following a life spent fusing hydrogen to helium at its core. However, what about Betelgeuse's era? This star, estimated to be between 8 and 8.5 million years old, is ancient in terms of stellar lifetimes but relatively young to humans. The red supergiant phase it is in now is the result of millions of years of stellar evolution, which was marked by significant changes and processes that brought it from a hot blue star to the red giant it is today. The relentless forces of nuclear fusion and gravity drive the story of transformation that is the life cycle of stars like Betelgeuse. Betelgeuse's particular ruddy tone is one more sign of its ongoing stage. The star's relatively lower surface temperature, when compared to other stars like our Sun, is what gives it its red color. Betelgeuse's cooler surface experiences temperatures around 3,500 Kelvin, whereas the Sun's surface is approximately 5,500 Kelvin. Betelgeuse is able to produce reddish-colored light thanks to this cooler temperature. In any case, this tone isn't simply a visual quality. It gives hints about the star's state of being and the cycles happening inside its tremendous vaporous territory. Betelgeuse's historical color change adds to its mystique. Antiquated Roman and Chinese compositions propose that close to a long time back, Betelgeuse was yellow. Arabic scholars first described it as red in the 9th century. This variety shift over mankind's set of experiences isn't simply a detail in that frame of mind of cosmology, yet a hint to the star's developmental way. Another intriguing aspect of Betelgeuse is its varying brightness. Because it is a semi-regular variable star, its light fluctuates frequently. Astronomers and skywatchers have been captivated by this variability, a distinctive luminosity dance, for centuries. Betelgeuse typically goes through a 400-day cycle and a longer cycle that lasts about 5 years. These cycles have been reported as far back as 1836 by Sir John Herschel and perhaps much prior in native oral customs. Be that as it may, what makes Betelgeuse genuinely confounding isn't simply its changing brilliance, however, its inconsistency. Not at all like many stars that follow an anticipated example, Betelgeuse sometimes digresses from its musical diminishing and lighting up, indicating complicated and less comprehended processes happening inside its Goliath structure. In a new notable disclosure, Betelgeuse caught the consideration of space experts and stargazers overall with a surprising and sensational change in its appearance, an occasion presently broadly known as the incomparable darkening. In late 2019, the red supergiant Betelgeuse, quite possibly of the most splendid star in the night sky and a conspicuous component of the Orion heavenly body, started to diminish bafflingly. The star's darkening was articulated to the point that it started losing its iridescence at a typical pace of 0.01 extents each day, arriving at its least splendor in February 2020. Betelgeuse, typically noticeable to the unaided eye even in light-dirted regions, turned out to be uniquely fainter, a change recognizable even to novice onlookers. In any case, there's one issue with attempting to screen the exercises of Betelgeuse: the time conundrum. Due to the length of time it takes for light to reach us, we cannot see a star like Betelgeuse in the present but rather in the past when we look at it. In the case of Betelgeuse, the star from which we perceive light today is approximately 725 light-years away. Because we are essentially looking into the past of the star, this time lag makes it difficult to anticipate and track sudden changes in its behavior. The Betelgeuse dimming event served as a reminder of the limitations of our understanding when dealing with vast cosmic scales and the time paradox they introduce, as well as the inherent difficulties of real-time astronomical observations. The unfurling of Betelgeuse's divine show was firmly observed by Andrea Dupree, partner overseer of the Middle for Astronomy at Harvard and Smithsonian, and her group. They used Hubble to break down the behemoth star as a feature of a 3-year study to screen varieties in Betelgeuse's external environment. These perceptions offered an exceptional knowledge into the elements of a variable star like Betelgeuse, which consistently grows and contracts, causing changes in splendor. The researchers were able to investigate the layers above the star's surface that were partly heated by the star's turbulent convection cells, thanks to Hubble's ultraviolet sensitivity. Further examination of the Hubble spectra, taken at various focuses all through 2019 and 2020, helped in estimating the development of material in Betelgeuse's external climate. Magnesium-2 lines, which are indicative of the star's atmospheric conditions, were the focus of the spectra. According to these observations, material was moving from the star's surface into its outer atmosphere at roughly 200,000 miles per hour. The dust cloud that eventually caused Betelgeuse's star to dim was the precursor to this hot, dense material, which eventually spread out millions of miles from Betelgeuse. Over the course of the 3 months following the outburst, Dupree and her team estimated that approximately twice the usual quantity of material from Betelgeuse's southern hemisphere was lost. This mass misfortune was huge, particularly taking into account that Betelgeuse, similar to all stars, constantly loses mass, but at a rate far more prominent than that of our Sun. The size of this mass discharge and the ensuing darkening started conversations among stargazers about whether this occasion could be a forerunner to a cosmic explosion blast. The vicinity of Betelgeuse, around 725 light-years from Earth, adds to the interest, as any such blast would be noticeable from Earth and give an intriguing and open door to notice a cosmic explosion very close. But there is still the question of what this dimming event means for Betelgeuse's future. Is it a sign of a looming cosmic explosion, or just a remarkable episode in the star's long and complex life? This sudden change was proposed to be explained by several theories. Due to the widespread belief that Betelgeuse is nearing the end of its life, one widespread theory proposed a phase in the process of the supernova explosion. Our view might be obscured by dust, possibly from the star itself, according to another popular theory. Like other red supergiants, Betelgeuse is known to shed material, which was thought to form a dust cloud dense enough to obscure the star's light from our perspective. A third explanation looked at changes in the star's visible surface layer, the photosphere, which could change how bright it appears. This mystery was deciphered through in-depth analysis employing various observational techniques. Spectroscopic examinations demonstrated a drop in Betelgeuse's compelling temperature, proposing that the diminishing could be because of a huge dim spot on the star's surface. This hypothesis was upheld by the perception that Betelgeuse's temperature decreased by something like 170 Kelvin around the hour of the diminishing, highlighting massive changes on its surface. In the end, the Hubble Space Telescope, which serves as humanity's watchtower in outer space, held the key to comprehending this peculiar phenomenon. Betelgeuse's dimming was most likely brought on by a significant ejection of hot material into space, according to Hubble's observations. Betelgeuse's light effectively decreased as a result of this material forming a dust cloud that obscured a portion of the star's surface. It was thought that superhot plasma erupted from a large convection cell on the surface of the star and moved through the star's hot atmosphere to the colder outer layers to form the dust cloud. As it cooled, it shaped dust grains, making a cloud that hindered light from about a fourth of the star's surface. The ultraviolet light spectroscopic observations made by Hubble, which began in January 2019, played a crucial role in establishing the time frame that preceded Betelgeuse's deterioration. In the months leading up to the dimming, these observations revealed evidence of hot, dense material moving through the star's atmosphere. The material had reached Betelgeuse's outer layers by December 2019, where it had cooled to form the dust that caused the star to dim. The fast cooling and development of this material recommended it was driven by the star's throbs, which are known to be a critical element in red supergiants like Betelgeuse's variability. This hypothesis of throb-driven mass misfortune is steady with different perceptions of red supergiants and gives a conceivable clarification to the occasions prompting the incomparable diminishing. In addition, Betelgeuse's dimming was not an isolated occurrence but rather a component of a larger pattern of behavior. The star has a long history of fluctuation, with centuries-old observations of cycles of brightness and dimming. The Great Dimming, on the other hand, was unprecedented in its scale and speed. This occasion gave an uncommon open door to cosmologists to concentrate on the late phases of a red supergiant's life continuously, offering experiences into the mind-boggling processes happening in these enormous stars. Our knowledge of red supergiants and their behavior, particularly in their final stages of evolution, has grown as a result of Hubble and other observations. The disclosures from the James Webb Space Telescope have carried new desperation to how we might interpret Betelgeuse. The possibility of a supernova becoming more likely with each passing day is pointing to the end of this ancient star, which is older than humanity itself. Now, the question is not whether but when Betelgeuse will burst. Will Earth's inhabitants be present for one of the most magnificent and terrifying cosmic events? Betelgeuse is on the verge of disaster, but the answer is still up in the air. It might be prudent to keep in mind that the universe is a place of unimaginable power and fury as we look up at the night sky. Betelgeuse may soon serve as a powerful and terrifying reminder of that fact.